Okay, so I will now be accepting yung mga student requests diyan. Ngayon, meron akong student dito from I think Mindanao State University ito, mechanical engineering din. As you can see on the background, nag-message siya sa akin na, "Sir, I need your help." And about this question daw. So ito, sinend niya, ayan, nasa si Miss Edlin Ria Alisbo, mechanical engineering student yan. So I'll try to solve the problem on the spot. Okay, as I am recording it now. Sabi niya, "Sir, how to solve po ba yung piston displacement if hindi given yung bore and stroke?" May maraming technique dyan. This is about machinery. Okay? Volume displaced, patingin nga ng problem. So, ito yung problem. Okay. So, let us focus here. Thank you dun sa tanong niya. Tignan natin kung kaya natin i-answer to, ha? So, ito yung problem. Air at 680 cubic meter per hour is compressed from, nagbigay dito ng absolute pressure, 1.055 kilogram per centimeter squared. Absolute. And 26.7 degrees centigrade to, ano yan, approximately 8 times the inlet pressure, assuming all clearances. Okay. All clearances are 8%. Determine the following: A, isentropic power, and the piston displacement required for a single stage compression. So, yan yung condition 1. Condition 2, the minimum ideal power for two-stage compression when the intercooler cools the air to the initial temperature. And C, the displacement of each cylinder if using the same data and condition of B. Asan yung condition niya? Ito. Yan ah. The heat exchange in the intercooler and the letter E. Hindi ko na iyan. The driving output required for two-stage compression. Ibig sabihin, the work output of the compressor if the efficiency is 78%. Now, first things first. Pag nagbigay dito, was it displaced or the capacity? So, the air at, nagbigay na siya dyan. Okay? 680 cubic meter per hour is compressed. It is yung, that is the air that is introduced to the system, or that is the capacity ng air compressor mo. Yan. Pag sinabing V1, pag sinabi yan, V1, ay yung volume na ibinigay dyan, that is the volume flow nung suction niya. Ibig sabihin, that is the air. Hindi siya yung air delivered. Okay? That is the air na inintroduce mo sa system. Ngayon, pag sinabing capacity, that is the displaced air. Okay? Displaced air. Pero hindi naman dito sinabing capacity. That is the air that is compressed. Okay? Hindi yan yung capacity. That is the air that is compressed in every hour. Ibig sabihin na yung ini-introduce mo doon sa system mo. Then, you can say na itong air na ito, 680 cubic meter per hour is actually V1. And then, ito is P1. Absolute yan. And then, this is T1. First, isolve natin yung isentropic power. When we are talking about isentropic power, that is the compression power of the single stage compressor. Okay, letter A. Isentropic power. That is equal to yung work of the compressor equal to K P1 V1 divided by K minus 1. Isentropic pag polytropic, that is N multiplied to P2 over P1 raised to K minus 1 over 1 minus 1. Okay, get back to the problem. Tignan nyo dito. Assuming all clearances are 8%. So, meron ang clearance na 0.08. And then, yung to approximately 8 times the inlet pressure, ibig sabihin you are given a ratio of the pressures. So, P2 over P1, ang ratio niyan is 8 to 1. Ibig sabihin, 8. Okay? Ito expression na to, 8 na yan. Then, we can get na yung power ng compressor. Isentropic to Iba yung isothermal, iba yung isentropic, iba din yung polytropic work. Okay? Pero dito specified as isentropic. Now, pag hindi naman binigay sa problem, work lang ang sinabi, that is automatically considered as isentropic work. Ngayon, pag binigyan ka naman ng pag sinabing work, pero binigyan ka diyan ng ng tawag dito. Yun nga, binigyan ka lang ng P1, B1, P2. Sinabi, i-specify pa rin naman na isothermal. The temperature is constant. Okay? Oh, let us get back here. Yung K mo, if that is air standard, that is 1.4. Multiply to P1. Yung P1 mo dyan is, i-convert mo na ito. 1055. Diretso ko na dito. Ha? Diretso ko na yung kanyang conversion. 1.055 kilogram per cm squared. Ang kailangan nating unit is in kPa, kilonewton per meter squared. So, 101.325 kilonewton per meter squared. Divide natin, ano ba yung kanyang conversion unit? So, 1.022 cm squared per kilogram per cm squared. Okay, yan yung conversion factor niya. Op, yan. Tapos yung V1 mo, convert mo ulit. Dire-diretso na, huwag ka na mag-convert ng pa isa-isa. 680 cubic meter per hour. Kailangan dito naka-seconds. So, you have 1 hour in every 3,600 seconds. And then, divide mo na pala dito ng 1.4 minus 1. Multiply mo nung buo. Ano ba yung binigay sa yung ratio of the pressures? The ratio of the pressures there is 8 raised to 1.4 minus 1 over 1.4 minus 1. Entirely. Ngayon, tignan mo yung unit. 1.032 ata to. Kung di ako nagkakamali. Tingnan natin yung kanyang sa term mo nandito yan. Ayun. So, 1.032 hindi 1.022. Okay? 1.022 naghahalo-halo na lang yung alam ko. Yan. 1.032. Yan. Tapos cancel natin yung same units. Kilogram per cm squared, kilogram per cm squared, hour, kilogram meter, isa matitira. Kilonewton meter is kilojoule. Natira dito, isa. Bali, kilojoule in every second, that is kilowatt. Wala namang in-specify dyan if that is HP. If that is HP or kilowatt. So, we assume kilowatt lang naman ang hinahanap na dito. Work of the compressor there is 1.4. Tapos, multiply mo ng 1.055. Kunin mo yung multiply mo ng 1.101.325. Okay. Kulang tayo dito. Yan. 1.032 kilogram per cm squared yan. Maka-cancel na yun. And then you multiply it again with 680 divided by 630. Hindi, 680. Divide by 3,600. And then, bago mo siya i-multiply nung sa kabila, dito na lang sa baba, 1.4 minus 1 is 0.4 na lang kagad. And then, you multiply it again with 8 raised to 0.4 na yung taas kasi 1.4 minus 1 divide by 1.4 and then minus 1 mo. The answer will be 55.57. 55.57 kilowatts. Approximately, kunin na natin. Divide mo na ng 0.746. 0.746 para maging HP. So, that is 74.49. HP. Okay. Yan na yun. Ano pa yung tinatanong dyan? Sa letter A. The piston displacement for a single stage compression. Ano ba? Pwede ba natin makuha yan? Okay. So, you have there a clearance. Clearance. Yan. Meron kang clearance. Saan mo ba makukuha yung clearance? Yung clearance. I mean, yung clearance kasi pwede mong gamitin sa volumetric efficiency, which is equal yung volumetric efficiency sa 1 plus C minus C multiplied to the ratio of the pressures, P2 over P1, raised to 1 over K. Pwede yan. Saan pa? Volume displaced. Pag volume displaced, pwede mo rin gamitin ito. Yung clearance volume or the V2 is equal to C V D. Makuha mo yung volume displaced, kaya lang may problema ka dito. Pwede rin naman, yung volumetric efficiency mo that is equal to V1 over VD. Yan. Itong EV ang problema mo. Kaya lang, meron ka ng clearance, di ba? Meron ka ng clearance. So, pwede kong gamitin ito para makuha ko yung VD. Di ba? Multiply ko lang. So, ito. Dito natin lagay. So, VD is equal to V1 all over 1 plus C minus C multiplied to P2 over P1 divide by 1 over K. Check natin, may V1 ka naman binigay dyan, di ba? So, 680 cubic meter per hour. Gawin ko na lang tong seconds. 3,600 seconds in every hour. Divide by 1 plus C minus C multiplied to P2 minus, divide by P1 raised to 1 over K. Diba? Ito, palitan ko na to. Okay? So, 680 M3 divide by yan, multiplied to 1 hour in every 3,600 seconds. Tapos yung clearance na binigay sa dyan, 1 plus 0.08 minus 0.08 multiplied to yung ratio of the pressures, that is 8 raised to 1 over 1.4. So, makuha ko na dito yung volume displaced. The volume displaced for the system is 680. Divide ko na lang sa baba. Okay? Divide ko na to ng 3,600. And then, 1 plus 0.08 minus 0.08, i-multiply ko ng 8 raised to 1 over 1.4. So, the answer will be, ganyan natin, that is the volume displaced in every second. So, 0.2599. Approximately 0.26 cubic meter in every second. Okay, that is the volume displaced. Sagot ko na yung tanong. How about B? The minimum ideal power ha, without losses for two-stage compression when the intercooler cools the air to the initial temperature. So, the minimum ideal power. So, isentropic pa rin yan for two-stage. Meron dyan shortcut na binibigay ako para makuha mo yung two-stage power. Pag multiple stage, two-staging, the minimum work, pag ideal, di ba? Ideal, meron kang work at the first is equal to the work ng second. So, note natin, sabi. Sa two-staging ng compressor, if I can still remember it ha, tagal ko nang di nagtuturo ng fluid machinery. So, yung work at the first stage is equal to the work at the second stage. Ganyan yun kapag ideal. Ideal only to ha. Nakalagay dyan, ideal. So, the minimum work, ibig sabihin po, kinuha mo yung sa 1, ganun din yung sa 2. Okay, pwede natin idiretso. So, for the work of the 2 staging, okay, that is 2 multiplied to n, hindi naman nagbigay ng n dyan, 2k P1 V1 over k minus 1. Tapos yung pressure niya dyan, may binigay ba dito? If the intercooler cools the air to the initial temperature. So what is the final temperature nito? Para makuha mo intercooling. So intercooling, wala naman binigay dito pressure intercooler. Ideal power lang naman, ibig sabihin, equal yung second sa first stage. O di multiply ko lang ng 2. So this is P2 over P1 raised to K minus 1 over K minus 1. Kaya lang, naka 2 stage ka dyan. Final pressure, 2N. N minus 1. Ito, multiply ko rin to ng K. Okay, ganun yung formula niya. So, this is 2 K minus 1, o di 1.4 multiply to P1, V1. Yung P1 mo is 1.055 tapos 1.032 times 101.325. Ang unit nito is kilonewton per meter squared. Tapos volume is 680 divide by 36 meter cube per second na. Diretso ko na yung computation niya. Divide by okay. So, ito binigay kasi sa iyo P2 and P1. Pero pag ito PX, yung dulo ng stage mo, this will be N. Gagamitin mo kapag multiple stages. Okay. So, 2K1, okay, 1.4 minus 1. And then, multiply natin ng 8 raised to 1.4 minus 1 over 1.4 minus, buo yan, minus 1. So, calculate natin kung ano. So, 2, times 1.4 times ko ng 1.055 times 101.32 and 5 divide by 1.032 tapos multiply ko ulit ng 680 divide ko ng 36 tapos divide ko ng 0.4 i-multiply ko ng 8 raised to 0.4 divide by 1.4 minus 1. Medyo mabagal lang ako dito sa ano to, mamamatay eh. Calculator na to eh, pag ginamit ko yung aking tab. So that is the minimum power. Okay? Minimum power is 111. Divide mo lang ng 2 para malaman mo yung first stage power niya. So 314 kilowatts. Approximately, multiply na lang natin ng, or divide natin ng 0.746. That is 148.98 HP. That is for the second staging. Next condition. Next condition C. Displacement of each cylinder using the same data in condition of B. Of each cylinder, ibig sabihin, hindi naman natin alam kung ilang cylinder dyan. So, displacement, ganito ulit na process ang gagawin mo. May clearance ka rin naman dyan, same. Okay? So, 1C A V1. Saan ko gagamitin to? Minimum power. Wala naman sinabi dito. Displacement of each cylinder using data at B. P1. B1. Walang binago. Okay. Okay. So, letter C, dun ko ulit kukunin. So, VD of each cylinder, bore ends. Okay. So, VD is, so V1 divided by EV. That is equal to V1 divided by 1 minus, ay hindi, plus C minus C multiplied to P2 over P1 raised to 1 over K. Mhm. Wala naman tayo intercooling pressure, kaya okay lang yan. Pwede na. So, V1 is 680 divided by 36. Okay, divided by 1 plus 0.08 minus 0.08 multiplied to 8 raised to 1 divided by 1.4. O, di same lang pala nito. Magiging same lang, wala namang binago eh. Ano yung nakuha ko dito? Volume displaced. That is 0.26 cubic meter per second pa rin. Yan. Hindi ko makuha yung tanong ha. Hindi naman ako nag-assume. Pina-follow ko lang yung problem. So, D, the heat exchange in the heat cooler, MCP delta T. Asan yung final dito? To approximate times the inlet pressure. Okay. Okay. Okay, meron kang P2. Okay, P2 is equal to 8 ng P1. Intercooler, ano nga to? P1. Oh, so, P2, P1. So, P1, P2. P2 is equal to 8 times 1055 kilogram per cm squared. Multiply ko lang. Kunin ko muna yung P2 ha, papakita ko sa inyo. So, 8 times 1.055. That is 8.44 kilogram per cm squared. Ayan na yan. May P2 ka. Paano mo kuha yung intercooler temperature? So, meron kang T1 over T sa intercooler. Palagay na lang natin. TI na lang to. Equal to P1 over P2 raised to K minus 1 over K. P2, yan, nakuha ko yung P2 ha. Ay, mali pala itong gagamitin ko. Ayan. Dapat to PX. Intercooler pressure. Tapos, intercooler temperature. TX. Ayan. Dapat ganito yan. Paano makukuha yung intercooler heat rejected? So, that is, yan, yung Q intercooler is equal to M, mass ng air, wala ka, CP, TX minus T1. Saan mo kuha tong M? Sa 1. Kuha mo yan sa 1. Q, okay. T1, meron na tayo. P1, meron na tayo. P2, meron na. Px, wala pa tayo. Px is equal to square root ng P2. Pwede na rin. Bali kasi P1 multiplied to P2. That is equal to square root ng P1 times 8 ng P1. That is equal to Px equal to square root ng 8 P1 squared. O di, square root of 8 multiplied to P1. That is 0.1055 kilogram in every cm squared. Okay. So Px is square root of 8 times 1.055. That is 2.984. 2.984. That is the intercooler pressure. Hanapin ko na dito yung Tx. So Tx is equal to T1 divided by T1 over Px raised to K minus 1 over K. Actually, kahit di ko nakunin si Px eh. Kasi Px is P1 square root of 8. Okay? Tx is equal to T1. Nandyan yung T1 mo, absolute mo dapat yan. I-absolute natin. Para kunin natin. That is 26.7. 26.7 plus 273. Degree Kelvin na to. Yung P1 mo, P1 over P1 square root of 8 raised to 1.4 minus 1 divide by 1.4. Cancel na natin yung P1. And the Tx will be equal to, mahabang problem to, 26.7 plus 273 divide by 1 over, dapat merong bracket dito. Yan. 1 over square root of 8. Bali, 2 square root of 2 yan eh. Raised to 0.4 divided by 1.4. 1.4. The answer will be 403 degree Kelvin yan. 403.37 degree Kelvin. Ayan yung Tx mo. Ngayon makukuha na natin si Q nung sa intercooler. Yung M ang problema natin. O di M. So yung bakit ang problema natin yung M? Tandaan nyo, that is coming from PV is equal to MRT. So yung 1, 1, 1. So M will be equal to P1 V1 over R T1. Oh, ito, sabay-sabay ko na isolve. T1, ayan. Sabay-sabay ko na isolve to. So, M is P1, that is 1.055 divide by 1.032 times 1.0 1.055 101.325 kilonewton per meter squared. Ayan, pressure na yan. Multiply to volume, 680 meter cube per hour. Hindi, per second na lang to. Divide ko na lang ng 3,600. And then, divide mo ng R. That is 0.2708 kilojoule per kilogram degree Kelvin. Okay na yan. Multiply din natin ang temperature, 26.7 plus 273 degree Kelvin na to. Yan na yan. May M na tayo. Cp of air, that is 1.0062 kilogram per kilojoule per kilogram degree Kelvin. Tapos yung temperature change, Tx. Okay, Tx minus T1. So, Tx minus T1. So, 403.37 minus 26.7 plus 273. The answer is 299.7 degree Kelvin. Cancel all the same units. Itong kilonewton, hindi. Meter squared, meter, may matitira ditong isa. Kilojoule, kilogram, Kelvin, Kelvin. Kilojoule, kilogram, Kelvin, Kelvin. Ang tira kilonewton meter second, that is kilowatts. The answer will be 1.055 times 101.325 tapos 1.032 times 680 divide by 36. Kasya naman sa calculator to. Was 0.28708 times 299.7 multiply to 1.0062 times 403.37 minus 299.7. Kasya yan. So, answer is ilan? Kilowatts. So, Q I ng intercooler, that is 23.72 kilowatts. Approximately, divide na lang natin ng 0.746. The answer is 31.798, approximately 31.8 HP. Yan. So, meron pa ba? Siguro napakahaba na nung aking sinagot dyan. Hanggang letter D. Okay. Driving output required for two-stage compression if efficiency is 78%. O, di-divide ko na lang to ng 78. So, yung letter E, yung work output, that is, yung work ng compressor divide by efficiency. So, that is, yung output ba? Driving output required for two-stage compression if efficiency is 78%. Driving output ng ano, ng air or the motor output to, I think. So, di-divide ko na lang yung 148. Wala man sinabi dito volumetric efficiency. Compression efficiency is 78%. Okay? So, i-multiply ba natin or di-divide? So, divide natin pag malaki yan. So, 148.98 HP. 0.98 HP. Divide by 0.78. Ito yung motor power na kailangan natin. So, 191 HP. Yan. Depende kasi ito sa nagbibigay. Minsan may ambiguity yung words. So, I think that will suffice for the request na student natin. I hope nakatulong tayo ng konti. Okay? That will be all.